You have 4w squared plus 6w plus 1 equals 0. Finding your ABCs will help us solve for the values of w. Did I use? Okay. So your A in this case is 4, your B is 6, and your C is 1. So let's not solve for the X, but we solve for W. Let's plug in your ABCs in your formula. B, 6, so we have minus 6 there, plus minus square root of 6 squared minus 4, A, 4, C, 1, all over 2 times 4. So what's our W now? You have negative 6 plus minus 6 squared, you have 36 minus 16 all over 8. Now this is negative 6 plus minus 36 minus 16. You have 20. All right, that's 20. All over 8. We know that 20 is not a perfect square. Now what we can do here is to factor 20, wherein one of the factors is a perfect square. So what are the factors of 20? 4 and 5. All right, we have 4, 5, and then 8. Take the square root of 4. What's the square root of 4 here? 2. So that's now plus minus 2. The square root of 5 all over 8. So what's next there? You distribute or you simplify it. What number divides 6 to 8? Do we have a GCF for the 3 numbers? If there's a GCF for the 3 numbers, you have to simplify it. So what's your GCF? What number divides 6, 2, and 8? 2. So we have a GCF there, which is 2. Now we use that to simplify our equation. I mean our answer. So what's negative 6 divided by 2? Negative 3. What is 2 divided by 2? That's 1, but you don't write it because that's the coefficient of the radical. All over 8 divided by 2, 4. You only do that if these 3 numbers here have a GCF. If they don't have a GCF, then do not. Then that will be it. So W is equal to negative 3 plus minus square root of 5 all over 4. And what's your solution here now? What's your solution, sir? Separate that. Negative 3, start with the minus, square root of 5 all over 4, comma, negative 3 plus square root of 5 all over 4. So that would be your solution set. Now, let's solve x squared plus 3x plus equals 0. It's in standard form. So we can identify your A, B's immediately. So what's your A here? 1. Your B? 3, C, 3. Let's solve for x now. Are we solving for x here? Or other variable? All right. Let's just make sure of that because a while ago I messed up with one of the examples. So we're solving for x. Now we have negative 3 plus minus square root of 3 squared minus 4 times 1 times 3 all over 2a, which is 2 times 1. Okay, now we have negative 3 plus minus square root of 9 minus 4 times 3. And that'll be 12 all over 2. 9 minus 12, negative 3. All over 2. And then, all right, what do we notice about this? Square root of negative 3 can be written as, in terms of I, how do you write this? 3, square root of 3, I, right? Square root of 3I. Now, for those of you who were not here before, let me show you that. Now, for those who were here in the lecture regarding imaginary number or complex number, you should know that square root of negative 3 is the same as square root of 3I. But let me show you why. Why is it? We have negative 3 plus minus. We know that we can factor negative 3 as 3 times negative 1. But note that square root of 3 times negative 1 can be written as square root of 3 times the square root of negative 1. But in section 9.7, we know that square root of negative 1 is an imaginary number. It doesn't have a real root. This one is not a real, it doesn't have a real root. So we can write this as the unit, imaginary unit number, which is square root of negative 1, and that is equal to I. Also, we note that I squared is equal to negative 1, right? But here we don't need the I squared. What we need is the square root of negative 1, which is equal to I. Therefore, we have negative 3 plus minus square root of 3I all over 2. And this square root of 3I here is the same as square root of negative 3. And that's your x. Therefore, we can write our solution set. Our solution set would be negative 3 minus square root of 3I all over 2. Make sure that I is outside the radical. Now we have negative 3 plus the square root of 3I. See, I is outside the radical. That's a proper way of writing. So we have this solution, and these solutions are not real. So you can say no real roots. Why no real roots? We have an imaginary number. We have a complex number there, so there's no real solutions. Forgive me for using the word roots. Yeah, but the proper term is solutions. There's no real solutions because the solutions are complex number, they are imaginary number. We have an imaginary number. It's a complex number. So there's no real solutions. As long as your solutions are complex number, then you can say no real solutions. But specifically what? Specifically what are these? These are the solutions which are not real numbers.